Recursive definitions. Sometimes a sequence is defined by giving the value of Tn in terms of a preceding term Tn minus 1. So if you're interested in figuring out any term called Tn, what you would do is use the term right before it, Tn minus 1. For example, if you're interested in getting the fifth term here, T5, what you would be using to do that is T5 minus 1, which is actually T4, that preceding term. A recursive definition is going to rely on the preceding term. Okay, and what we're going to do is develop a formula that we can use to keep generating the next term in the sequence, but it's always going to be based on that preceding term. Okay, a recursive definition consists of two parts. You have to have these two things to actually make it work. One, you need an initial condition. That tells you where the sequence starts. In other words, that would be T1. You have to have T1. The second condition is a recursive equation. That would be like a formula. Okay, a recursive equation that tells you how any term in the sequence is related to that preceding term. It tells you exactly how to use that preceding term to create the next one. Example 1, we're asked to find the first four terms given T1 as 3 and Tn as 2 times Tn minus 1 plus 1. Okay, so what we have here is a recursive definition because we're using Tn minus 1 to generate the next term Tn. Okay, this recursive definition tells us that we have to take the preceding term, multiply it by 2, then add 1. All right, so if T1 is 3, what we're going to do to figure out T2 is take that value and plug it in for Tn minus 1, which here we're going to show that already filled in with a T1. Okay, so the 3 is going to go here. That means that it also goes here. We're going to get 2 times 3 plus 1, which is going to give you 7. So T2 is 7. Okay, to get T3, we're going to take that last answer. This is that recursive definition. You're going to take that last answer and you're going to plug it in to the same formula behind that 2. Okay, so that'll end up here. 2 times 7 plus 1 is going to give you 15. Then to get T4, we're going to take that answer and plug it into our definition, which is going to give us 31. Okay, so overall, the sequence that we have here is going to be 3, 7, 15, 31. ... because we will continue on. For examples 2 and 3, we're going to be asked to do the same thing as in example 1, which is to find the first four terms of a sequence given a recursive definition. So for example 2, we start with 4 as our T1. That'll be our first term. The recursive definition tells us that we need to take our preceding term. So to get T2, we're going to take 4, we're going to take that value and we're going to square it, then subtract 10. Okay? Which of course is going to give you 16 minus 10, which will give you 6. Okay, and then after that, you're going to take this answer and just go ahead and plug it in again. You're going to have 6 squared, which is 36. Take away 10, will give you 26. All right, and then for T4, we're going to take 26 and square it, which gives you 676. Gives you 676, which will subtract 10 to get 666. ... because it would continue on here. In addition to what we just did, I want to show you that on some calculators, you can actually build off of your last answer fairly nicely. Okay, so for a TI calculator, if you have your first term, what you would do is just go ahead and type that in and press enter. So it's already there, and that's your first term. Then to type in the recursive definition, what I'm going to do, I'll go ahead and type in the parentheses just so you see them there. Okay, in the parentheses, what I'm going to tell the calculator to do is to recall the last answer that it had, which is going to be the 4. To do that on this calculator, I have to press second, then press the negative button. Above that, you're going to see ANS, which is going to bring up your last answer. Okay, I'll close parentheses, go ahead and square that, subtract 10. Okay, so we have this in there, except instead of Tn minus 1, I've typed in ANS, which refers to the previous answer. In this case, that would be a 4. So when I press enter, it's going to take that 4, go ahead and square it, then subtract 10. So your second term is 6. Then you can immediately press enter. It's going to take the 6, plug that in to get the next answer. You can press enter again, pulls up the fourth term, 666. And of course, you can continue to do this as long as you need. At some point, you might get values that are a little bit too large here, so it goes to scientific notation, but the idea still applies that you can build off of that last answer. For example 3, you actually get two terms to start with. You get T1, which is 2, and you get T2, which is 4. So you've already got half of what were required, first 4 terms. You've already got the 2, you've already got the 4. So we need 2 more terms. So what is the reason for getting 2 terms? Because in the previous problems, all you needed was that first term and being able to build off of it. Okay, but in this recursive definition, which we have over here, Tn is going to be equal to the product, that's multiplication there, it's going to be equal to the product of Tn minus 1, which we know to be the preceding term, and Tn minus 2. Okay, so what is Tn minus 2? Well, if Tn minus 1 is the preceding term to Tn, then subtracting 2 from n is actually going to find the term that would be 2 preceding it. So this is actually telling us to get the nth term, you need to take the product of the 2 preceding terms. So we get 2 terms to start with. That way we can actually create the third one. The third will be the product of these 2, which is going to be 8. Okay, now to be really clear here, the 4 is actually the Tn minus 1. The 2 is going to be the Tn minus 2. That is 2 preceding what we just found. To get the fourth term, what we'll do is multiply the last 2 terms that we have here, which will be the 8 and the 4. So that'll give us 32. And of course, you can continue that pattern out as well. For example 4, the population of a certain country grows as a result of 2 conditions. The annual population growth is 1% of those already in the country. Also, 20,000 people immigrate into the country each year. Part A, write an equation for Pn, the population in n years. Okay, so we got to think this through, and of course, this is going to be a recursive definition that we're writing because of the way that the prompt is described here. We need to start with the preceding population, which would be Pn minus 1. Whatever you had at the beginning of a year. You have Pn minus 1. We're trying to figure out what we're going to get the next year Pn. Okay, that current population has to increase by 1%. To do that, you're going to need to multiply by 1.01. Multiplying by 1.01 is going to do 2 things here. The 1 in the front is going to maintain the current population. The 0.01 is going to add on that extra 1%. Okay, in addition to that, in addition to taking the original population or the population the year before and multiplying by 1.01 to get that 1% increase, we also have to account for the 20,000 people that immigrate, which is going to be an addition of 20,000 after the 1% increase. Okay, so this is the formula for Pn. Part B, if the population is currently 5 million people, what will be the population in 20 years? Okay, now the one thing that I got to tell you from the very beginning is that with recursive definitions, the chance that you can just jump 20 terms forward is not very likely. Okay, you probably need to go through all the terms, in which case the fastest process for this is going to be using a calculator where you can take your last answer and build off of it. All right, let's go ahead and see what that looks like. We're going to take our 5 million and just hit enter, so we have that already in there. And then we're going to run our equation building off of that answer 20 times. Okay, so I'm going to type in ANS to recall my last answer, multiply that by 1.01, and then we're going to add on the other 20,000. Okay, so at the end of 1 year, or the population at P1 is going to be 5,070,000. Okay, and if I press enter again, that would be 2 years in the future. We'd have that population. So all we're really going to do is keep count. Okay, so that was 2. This will be 3, 4, 5, 6, 17, 18, 19, 20. That will be our population in 20 years. We're going to get, let's see if we can count all our spaces, 3, 3. Okay, we're going to have 6,541,330.28, which we could probably just drop off for this problem. Yeah. I'm going to go ahead and show you one more thing here that you may or may not be able to do with your calculator. If you have a TI-84 or a TI-83, you should be able to do this. Other types of calculators, not really sure if you can. If you don't have this feature, it is not the end of the world. It's just kind of a neat thing that the calculator can do, and not many people know about it. Okay. All right, so what we're going to do is create a set first. Okay, and to do a set, I'm going to use braces instead of parentheses. Okay, so I'm going to press second, parentheses, but you're going to notice a little brace comes up. In those braces, I'm going to type in 0, 5 million. Go ahead and close the braces and just press enter. Okay, what I've done here is I've created a set that's got two numbers in it. It has a 0 and it has a 5 million. So the 0 is going to represent times 0. Okay, and the 5 million is going to be the initial population. Okay, now what I'm going to do is create another set using braces. And for the first element of that set, I'm going to take the 0 and tell the calculator to add 1 onto it. Okay, so I'm going to type in answer. So it recalls my last answer, but I have to be very specific that it refers to the first element here, not both of them, right? Okay, so in parentheses, I'm going to type in a 1, which tells the calculator to look at the first element here. Okay, and that element, I'm going to add on 1 so we can see it change to a 1. We're going to press comma to separate them. Then for the 5 million, what I'm going to do is type in our P-N equation. Okay, so start with answer, but in parentheses, I'm going to put in a 2, which is going to indicate the second answer. Then I'm going to say that that gets multiplied by 1.01, close the parentheses, and add on 20,000. And we close the braces. Okay, and when I press enter, it should give me the population after 1 year, which was that number. You might not recall it from beforehand, but that was the population at 1 year. Okay, so the neat thing about this is I don't actually have to count things as I keep pressing enter. I just press enter and it gives you the next one and the next and the next and the next. And you press it until you get to the end value that you want, which is right there. So you don't have to keep count of them. You just go ahead and keep pressing enter until you get there. You might not choose to use this as a feature, but it does exist. Those of you who want to practice this, if you have a calculator like it, feel free to do so. On some occasions, it's pretty darn convenient.
Wait, what?